Hello again, welcome to another lesson in geometry. Today we are covering section 9-5 on dilations. So dilations are another transformation, however they are not in isometry because they change the size of shapes. So the shapes will no longer be congruent, however they will be similar to each other. All right, so complete each statement with the word ratio or similar. So the first one, number one, should say the ratio of the corresponding parts of similar figures is the scale factor. So if we change a small one into a big one, maybe this is 2 and 5, then the ratio would be 5 divided by 2, the new one divided by the old one, for a scale factor of 2.5. Okay, so you could tell that that's right because the new one's getting bigger. So if I times the old one by 2.5, I get the new one. You can use the scale factor to make a larger or smaller copy that is similar to the original figure. Okay, so the two shapes should still look the same, they're just different sizes. Okay, all the corresponding sides will be proportional and all the angles, corresponding angles, will be congruent. Okay, so circle the scale factor that makes an image get larger than its pre-image. So all of the ones that are smaller than 1 will make the image become smaller than its pre-image, so the only one that's bigger is 4/3. Circle the scale factor that makes an image smaller than its previous pre-image. So all the ones bigger than 1 will make it get bigger. So the only one smaller than 1 is 1/4. And by the way, a scale factor of 1 just makes congruent shapes. Okay. Dilation, a new word. Okay, a dilation is the widening of an object such as a pupil or the eye or a blood vessel. A math usage for dilation is a transformation that reduces or enlarges a figure so that the image is still similar to its pre-image. Similar is important here, okay? All right, related words are reduction, enlargement, scale factor, and center of dilation. An example, an enlargement of a photograph or the model of a solar system. So if we make an enlargement of a photograph to maybe make a poster, then we did a dilation. Or if we make a model of the solar system, we did a dilation. This one has a scale factor greater than 1, and this one has a scale factor much smaller than 1. Okay? All right. Use your vocabulary. Underline the correct word to complete each sentence. A dilation is an enlargement if the figure increases in size. Okay. Cross out the transformation that does not have a center. So remember, rotation needs a center, so we know what to spin it around. And we just said a dilation needs a center to tell where to expand it or contract it from. But reflection doesn't use a center, it uses a whole line, so not a single point. Okay. Circle the transformations that are isometries. So isometries are going to preserve size. So reflection is going to be isometry. You're going to make congruent figures. Rotation will make congruent figures, but a dilation is going to change the size, so the figures will no longer be congruent. Therefore, it is not an isometry. All right, let's flip it over and take a look at page 2. So on the second page, we have a key concept here, dilation. So a dilation with center C and a scale factor of n, and in this case, n is greater than 0, is a transformation with these two properties. The image of C itself, that is C prime equals C. So this is our center of dilation, and the center, when I dilate the center, it doesn't move anywhere. So C will stay right where it is. Okay. However, for any other point like R here, the way to get the new image from the pre-image is we're going to multiply the length of the original distance from C to R by our scale factor n, okay, to get the new distance from C to R prime. All right, so C R prime is equal to, so the distance from the center to the new R, the scale factor times the center to the old R. Or you could say the scale factor is the new distance, the center to R prime, divided by the old distance, the center to R. Okay. So the image of a dilation is similar to its pre-image. Okay, so notice in this case, this triangle here is similar to this triangle because the image is similar to the pre-image. Okay, corresponding parts will be proportional and the corresponding angles will be congruent. All right, so for the image of dilation, it's similar. So for a dilation of triangle PQR with a scale factor of 2, then the distance from C to R prime is equal to 2 times the distance of C to R. Or if it was a scale factor of 3, it would be 3 times the distance of C to R. Also, the distance of PR, or the distance of the new image, P prime R prime, would be the scale factor times P to R. Okay. All right, problem number 1, finding a scale factor. So we have our original image, the pre-image here, JKLM, and then we have the new image, J prime, K prime, L prime, M prime, and they should be proportional because we did do a dilation. The center of our dilation was the origin, so right here in the middle. So we could find some distances. It's easy to see a couple of them. The original distance from O to J was 2. So our pre-image was O to 2, but the new distance is only 1. Okay, so only 1 long. So that got half as big. Okay, it happens that for all of the points, and we'll see why in a second. All right, so underline the correct word to complete each sentence so we can find the scale factor of the dilation. So the image is definitely larger. Sorry. The image is smaller than its pre-image. So the green one is smaller than the blue one. The dilation is a reduction in this case. We took the blue one and reduced it until we got the green one. And then how can you tell which segments are corresponding sides of JKLM and J prime, K prime, LM, and M prime? Okay, and here's a possible answer you could write. The corresponding sides have the same letters as endpoints and are listed in the same order. So you could find them by just looking at the order in which they came. So for instance, M and M prime are going to be our corresponding angles, and ML and M prime, L prime will be our corresponding sides. So let's circle a side here. Circle the side that corresponds to JK. All right, so JK is going to correspond with J prime, K prime. So J prime, K prime. All right, now find the lengths of each one of those. So we want to find the length of JK. So first let's write down what points J and K are at. So J is at 0, 2, and K is at 6, 0. All right, so we'll find the length of JK. So we're going to do the difference in the x coordinates, so 6 minus 0 squared, and the difference in the y coordinates, so 0 minus negative 2 squared, and then we'll add those up, so that becomes 36 plus 4, which is the square root of 40. Okay, and then we want to find the distance from J prime to K prime. All right, so let's do J prime's point first. J prime is at 0, 1, and K prime is at 3, 0. So we'll find that distance. So this is going to be 3 minus 0 squared. And then the difference between the y's are 0 minus negative 1 squared. So that's 9 plus 1 for the square root of 10. Okay. So find the scale factor. The scale factor is going to be found by doing the image divided by the pre-image. So the images is square root of 10. The pre-image is square root of 40. So we can just put them both under the same house, so 10 over 40. Okay, and then that would make the same as, I'm going to write it one more time like this, square root of 1/4. And then the square root of 1/4 works out exactly to be 1/2, because 1/2 times 1/2 makes 1/4. So our scale factor is 1/2. And you might have guessed that anyways if you go back and look at the picture. Remember we said very back in the beginning of the problem, the distance from the center of dilation to J was 2, and the distance from the center of the dilation to J prime was 1, and our scale factor should be the new distance divided by the old distance, which is just 1/2. which is just what we found. So you can use it from the distance from the center out, or you can measure two of the sides and find that the scale factor that way, comparing the two sides. All right, let's flip it over and see what's on page 3. Okay, problem number 2 on the third page. Big problem number 2 is finding a dilation image. So what are the images of the vertices of triangle PZG for a dilation from center 0, 0 and a scale factor of 1/2? So we want to make our new image be half as big as the pre-image, okay? So after you do a couple of these, you can find this trick that they're going to tell you about, and this is how it works. So first off, we need to know the coordinates of the original triangle. So we have 2, 0 for P. Z is at -3, 1. Okay. And G is at 0, -2. So the center of the dilation, one more time, is 0, 0, and we are given a scale factor of 1/2. So our job is to find the new coordinates, and this is our plan. We could just take the old coordinates, okay, and multiply them by 1/2 for both the x and y. Those are our scale factors, and we should get the new image. So let's see how that works. So the pre-image for P was 2, 0. The new image will be times by 1/2 to both of the coordinates. So our new image will be 1 and 0. 2 times 1/2 and 0 times 1/2. For Z, our pre-image was -3, 1. Okay. Our new image will be half of that. So we're going to get -3/2, or -1.5. I'm going to put -1.5 here. And then half of 1, which is 0.5. Okay. And G's original image was at 0, -2. And if I half both of those coordinates, I'm still going to get 0, but -2 is going to change to -1. All right, so now our job is to graph these. So we've done what we think is our scale factor times the coordinates, and let's see if it works out right. Okay, so let's see. P is supposed to change to its new image at 1, 0. So 1, 0 is going to be right here. Notice the scales are going by halves. So this will be P prime. Z changed to -1.5 and 0.5. So -1.5 is here, and 0.5, that's up there. Okay, so this will be at Z prime. And then G is supposed to change to 0, -1. So this will be G prime. And this will be our new triangle, which should be similar to our original triangle. Okay, so graph the images of PZG on the coordinate plane, and then graph P prime, Z prime, G prime. And that works out for us. Okay, if we take a look at it real fast, look at our points. Notice P prime is 2 of these marks, and P was 4. So that's half as big. Same with G, this was 2 for G prime and 4 for G, so that's half as big. And if we do this and think about it, this is 3 over and 1 up, and then to get from Z prime to Z is 3 over and 1 up, so that's half as long also. All right, so we did find the correct image here. Okay, number 3, use a scale factor to find the length. So the height of a document on your computer screen is 20.4 centimeters. When you change the zoom setting on your screen from 100% to 25%, so this is getting smaller. The new image of your document is a dilation of the previous image with the scale factor of 0.25. Well, that makes sense. We do 25 divided by 100, and we get a scale factor of 0.25. New divided by old. That's how you find your scale factors. Okay. So underline the correct word to complete each sentence. Scale factor is 0.25, which is less than 1, so this is going to be a reduction. Our image is getting smaller. Image length, the scale factor times the original length. So the scale factor is 0.25. And we want to know the original, new height. The old height was 20.4. So if I times those together, we get 5.1 centimeters. All right, let's flip it over and look at the last page here. As always, we usually end up with a lesson check on our last page. So pause the video, go through the lesson check yourself, and then come back and see what you knew. Okay, talk to you in a minute. Okay, welcome back. So for our lesson check, we have a do you understand? And this is an error analysis. So the blue figure up here, the little blue one, is a dilation of the big black triangle, okay, from center A. So notice A did not move, just like it's not supposed to. And then like this point right here got pulled into here, and this one got pulled into there. So this is definitely getting smaller, okay? So 2 students made errors when asked to find the scale factor, explain and correct their errors. So one student said, hey, it's 1/3, and the other student said it's 4/1, which just turns into 4, okay? All right, so let's write T or for true or F for false for each one. So first off, was this dilation an enlargement? This is definitely false. Okay, this was not an enlargement, this was shrinking. So we can tell right away that this guy over here for B is definitely wrong. A scale factor of 4 should make the blue one be bigger than the black one. Okay, so the side lengths of the black triangle are 6 and 3. And this is also false. This is the problem that A had. Okay, the side lengths are not 6 and 3. The side lengths are actually 8 and 4. The whole length, which is 2 plus 6 and 1 plus 3 for the other side. So the side lengths of the blue triangle are 2 and 1. This is true. And the scale factor is between 0 and 1. This is going to be true because it's getting smaller. Okay. So explain the error that student A made. Okay. Well, student A used the wrong length for the original image, the pre-image. Okay. So student A used the wrong length for the pre-image. Okay. So they should have done something like this. Theirs would have been instead the new one divided by 2 divided by the original or the pre-image, which was 8, and should have gotten 1/4. Okay, so 2 to 8 is what they were looking for. They got confused and used 2 to 6, but remember 6 is not the whole length of that side of the triangle for the pre-image. It's just part of it. Okay. Now explain the error the student made in solution B. Okay, so in solution B, the student didn't write the image length in the numerator. So let's write that down. So remember, for our ratio, you're supposed to put the new one up top. They put the old one up top. They did 8 to 2. So they put the pre-image on top and the image on the bottom, and you're supposed to do it the opposite way. So that's why that's bad. Okay. So the actual scale factor should have been 1/4, like we calculated here, which is the pre-image of 2. I'm sorry, the image of 2, the new one, divided by the pre-image of 8, the old one. It's always the new on top, which is our image, over the old on the bottom, which is our pre-image. Okay, so 2 divided by 8 will give us 1/4 for the scale factor. The blue one is 1/4 as big as the black one. All right, so check off the vocabulary words that you understood. Hopefully you know what dilation is. That's changing our size, and we can either enlarge it or reduce it. Okay, but to do that, we have to have a center for which to change it from, and a scale factor for how much to change it. All right, so hopefully you're over here for understanding dilations of images and figures, but if not, watch the video again and then come for some extra help before our next class. I'll see you then.